Hello and welcome back to the Azure Terraformer. Today we have another Leap lecture where I give a bit of an overview to my Leap intern about different topics as we're onboarding them onto the team and helping them with their project that they work on as part of the Leap program. And so today we're going to be talking a little bit about Cosmos DB and Azure topology, a little bit about the nature of Cosmos DB and its, the fact that it's a multimodal service, meaning you can flip it into different gears, MongoDB, Gremlin, NoSQL, and the way that application software typically integrates with Cosmos DB, as well as kind of looking at some of the trade-offs of different high availability and disaster recovery strategies, and why Cosmos DB is so desirable just in terms of the things that were challenging, not impossible, but challenging before with relational databases, becomes so much easier with a service like Cosmos DB. So hope you enjoy it. If you're enjoying this Leap series, definitely smash that like button and consider subscribing to the channel. It really helps out a lot. Big shout out to our channel members. Thank you so much for your support. Really helps out a lot. If you're new to Terraform or you're new to Azure, definitely head over to Udemy and check out my new Udemy course, Terraform 101 Azure Edition. Also, if you're just interested in growing your knowledge of the multi-cloud, check out my book, Mastering Terraform. Links in the description below. Without further ado, let's get started. We have an Azure subscription. That's what do we call that? That's our house. We have a room in our house, which is a resource group. Inside that room, we can put some stuff. And one of the things that we can put in our room is a Cosmos DB account. Now, a Cosmos DB account is multimodal. Do you know what that means? Do you know how to drive a stick shift car? Gosh. Let me search for another metaphor. Wonderful. Can you be in the third gear and the fourth gear at the same time? One could say that a motorcycle or a car is multimodal because you've got different modes that you can put the engine in. First gear, second gear. I don't know why I did that, because can you be in reverse and park at the same time? So I probably didn't need to go with, okay, lessons learned. I like driving stick. Anyways, yeah, you can't, right? It's either you're in reverse or you're in drive or you're in neutral or you're in park. That's it. Cosmos DB is the same way. You're either I forget what they call it now. It used to be called SQL database, which is, I'm going to look it up because this is really annoying. They keep renaming this crap. They call it NoSQL now, which is better than what they used to call it. You can create a Cosmos DB account as a NoSQL Cosmos DB account, or you can create a Cosmos DB account as a MongoDB, etc., etc., etc. Anyways, so we got inside here, we can create what are called containers. Okay. Now, a container is where we actually store data. So we have our .NET app. Our .NET application is going to write to one or more containers in order to save data. So, what is a container? A container is kind of like a table, except every row in a container has a unique ID, and it has a partition key, and then it has a bunch of other, JSON data. That's pretty much what the data looks like that we put into our database. You don't have to create a database. So you can create a container and you can tell Cosmos DB. So Cosmos DB doesn't give you servers. Notice I haven't ever said how many virtual machines or how many servers we have. Basically, Cosmos DB says, I'm going to grant you a certain amount of frequent flyer miles, right? I'm going to give you 100,000 frequent flyer miles, right? And your .NET application can use those frequent flyer miles as much as it wants. This is all within a region. So the US West, right? US West. Okay. By default, but by default, you're in a region. So interesting aspect. Cosmos DB can also be set up with replicas. So like by default, this Cosmos DB is in US West. I could also add like a replica. And the replica is going to be for US East. And then by default, all of my containers, that are in this account are going to be replicated to US East. And so what ends up happening is my application can either hit the US East endpoint or the US West endpoint. So by default, like when you provision a Cosmos DB account to your primary region, you get an endpoint in the primary region, right? So it's going to be like my Cosmos DB account US West, right? And so I can point my application at the US West endpoint, and that's going to hit my container, right? So if I host my .NET application in US West, right, then I would probably configure it to point at the US West endpoint of my Cosmos DB. I can also deploy another copy of it's the same application in US East. Okay, let's just like pretend we don't need to know how they did that. And I would configure my application to talk to the US East endpoint. And then I would have my load balancer that would sit in front of these two copies of my application, and I would route traffic. So we both live on the East Coast. I live in Ohio. You live in Florida. We would probably get routed to the US East endpoint. We would make updates by hitting the US East endpoint because we're using the US East copy of the application. But it would hit the same container, and as soon as our write is done to that container, that update will get replicated to US West as well. So if by chance I hop on a plane and fly to California and then access the application 2 minutes later, 30 seconds later, 10 seconds later, 5 seconds later, 2 seconds later, and I hit the application, I would get routed to US West. That application would hit the US West endpoint. It would hit the container, and the data that I just wrote to US East, because I was in Ohio 2 seconds ago, would come back from the US West endpoint as if nothing happened, right? That's the amazing power of Cosmos DB. Cosmos DB is a service. We have a team at Microsoft that builds the service, and their service runs on our team's hardware. So you and I both currently work in Azure Core. Azure Core is responsible for compute, network, storage. Cosmos DB, I think they draw a dependency on Service Fabric. Long story short, ultimately, when Cosmos DB provisions across all the Azure regions, they're allocating our virtual machines. But like when you provision a Cosmos DB account, you don't have to think about the VMs at all. But at the end of the day, somebody is. Cosmos DB, like basically they provision VMs across every region, and as customers set up Cosmos DB accounts and they provision containers and databases that consume frequent flyer miles, if a certain number of frequent flyer miles are allocated, it'll trigger a threshold, and Cosmos DB will be like, oh, we need more VMs. So then they'll come to us and be like, hey, we need more VMs because we just, we had like a really great day today. We had like 100,000 customers come, and we gave them 100,000 frequent flyer miles each. And we only have VMs that can handle, 90% of that. So we need 10% more VMs, right? And then they'll add more VMs. Their customers have no clue, right? Their customers have no clue that this is happening behind the scenes, and they don't need to. And that's the benefit and the power of using a service like Cosmos DB, because it normally, when managing a database, you kind of have to think about like failover and redundancy and high availability and like disaster recovery and backup. And, you still have to think about backup, but it's like if if I deploy a SQL database on a single VM, if the hard drive crashes, I'm toast. What are my options? Restore from backup, spin up a new VM, load the backup onto my hard disk, and start my SQL database again. That takes a crap load of time, right? That sucks. I don't like that. So what can I do? Well, I can set up SQL Server in what's called active passive, or AB failover. So I set up 2 SQL servers. I synchronize them together so that they're like talking to each other. And between the 2 of them, one is the primary, or the A, or the alpha. This is why it's called AB. And then one is the beta, B. And basically the beta is the passive one that's like not handling traffic, whereas the alpha is handling traffic. Now, let's say the alpha server's hard drive crashes. Bada bing, bada boom. Instant failover. The beta server is already up to date, so it becomes the alpha. And now all traffic's going to the alpha server, which used to be the beta server. And then that gives me time to go like fix the old alpha and get it back up and running, and like add and fix the hard drive and all that stuff. Of course, on the cloud, like that, this becomes a lot easier as well. But you still have to do it. You still have to do this process with AB failover type scenarios. That's the problem, is like with SQL Server, you can't really do AB across regions. Yeah, it becomes, because there's like if so, what you can do, it's called synchronous versus asynchronous. Sync. Have you heard of sync versus async? That is correct. So with relational databases, you can, like, if you want to have a synchronous replication, meaning my US East application traffic writes one record to the database. I don't, like, in a synchronous situation, I don't respond back to the application until the write takes place here on A and B. That's called synchronous, which is what you just described. That guarantees the audit trail of the changes to the database between these 2 things. So if A ever fails and we need to switch over to B, then we have a higher guarantee of data integrity. Like, we don't have missing records. When the reason why you can do synchronous is you can only do synchronous if there's a certain amount of like latency between the 2 systems. You can do that if they're in the same region, but when they're not in the same region, the latency gets much higher, because the traffic, each request has to be trafficked way across the country. That adds additional latency. it doesn't seem like it's a lot of latency, but like if you think about every single database transaction, like you're adding 100 milliseconds, that's a lot. That's a lot of latency, which is why a lot of times people set up relational databases with async replication, which basically means I might have this database over here, and this is more of like an aggressive DR strategy, disaster recovery strategy. I am only going to rely on this Charlie database if the entire US East region goes down. Then my traffic can start, my traffic gets redirected from US East to US West, right? So disaster recovery strategies and high availability strategies, there's definitely levels of cost. And the scale goes like this. Like you've got active passive, and at the very tippy top you got active active. Okay. So active is where you're gonna spend the most amount of money. It's like we got $4 signs here. Okay. Active passive is where we have more like maybe $2 to $3 signs. Okay. And then way down here, we have backup. Okay. And backup is dirt cheap. Okay. So we have $1 sign. Okay. So on the scale of high availability strategies, these are kind of the ranges, right? And so as you would imagine, active costs the most money. What do you get for that? You get faster failover, right? Meaning users, we'll call what is this? Less user impact. If I'm using your web application, if I'm bouncing around on Amazon.com and US East goes out, an active scenario would be like, I click the next page and I have no idea that there was any downtime. I'm now on a page being served up by US West. And maybe the first time that I got switched over, there's a little bit of a blip, but it's like, okay, I move on. No, barely notice any difference, right? Active passive, there's you do have well, let's call this instant failover. This is, you have faster failover, right? Meaning, and let's call this no user impact. Okay. Less active passive. The alpha server goes down. We have to cut over to the beta server. There might be like a minute, where we lose some stuff, right? So we have less user impact, but it is fast. Now, backup is, I keep 24-hour backup, and the server crashes, and basically I have to have Joe Bob down in IT go spin up a new server, load the backup, verify the backup, and reconfigure the whole server to get it back online. So we're gonna have an outage window, okay, which could be 4 to 8 hours potentially for Joe Bob down in IT to go set up this server again. Now, what are the trade-offs? Well, it's cheap. It's super cheap. So you have to decide what you want to pay for, right? Then there's also this thing called like an RTO. Have you ever heard of RTO? RTO stands for recovery time objective. Basically, how long does it take you to get your service back online? So what would the RTO for an active-active solution be? Less than 5 seconds. What about active-passive? Sure. And then backup? Exactly. Now, recovery point objective. This is how much data did you lose? There's none. There's no data loss, right? Active passive, maybe 1 minute. Backup. If I have a 24-hour backup window, I back up every 24 hours at midnight, and my server crashes at 11:59 p.m. How much exactly? Whatever your backup frequency is. So this is why people choose different solutions like Cosmos DB and like SQL database, right? And so SQL Cosmos DB sits right here, right there, baby. Okay. SQL database, really advanced SQL servers can be set up here. You can also have SQL servers set up like this.